Welcome to this explainer. Have you ever looked up at the night sky and just felt incredibly small? Well, strap in because we're about to dive into the mind-bending reality of our cosmic address and the invisible, colossal force that is quite literally dragging our entire galaxy through space. Wait until you see the true scale of the structure we live in and the cosmic mystery that lies at its very heart.
All right, let's just jump right into this deceptively simple question. What exactly is pulling our entire galaxy across the universe? We kind of like to think of the Milky Way as just drifting peacefully through the void, right? But the reality is way more chaotic. We're actually caught in this massive cosmic tug-of-war, literally hurtling at staggering speeds toward a destination we can't even clearly see.
Part 1. Our tiny cosmic bubble. We're starting the cosmic zoom out.
Now, to understand what's pulling us, we first need to figure out where we actually are. Let's start with the absolute farthest reach of our civilization, the human radio bubble. This spans about 100 light-years in every direction from Earth. Basically, it represents every radio and TV broadcast we've ever beamed out into the cosmos. And sure, 100 light-years sounds massive, but compared to the Milky Way, it's literally a blip. Beyond this tiny bubble, it's as if humanity doesn't even exist. Any alien civilization sitting just outside this perimeter would be completely oblivious to us, because our signals simply haven't reached them yet. So, if we zoom out just a bit more, way past our radio broadcasts, we hit our physical stellar neighborhood. Scientists actually recently proved that we're sitting inside a 1,000 light-year wide void called the local bubble. Picture this. About 14 million years ago, a chain of around 15 massive supernova explosions went off in quick succession. The sheer force of those dying stars just blasted away the surrounding interstellar plasma, carving out this relatively empty cavity in space. And the craziest part? Our sun and all its planets are currently just drifting right through the dead center of it. It's so fascinating, researchers actually compare the cosmos to Swiss cheese. These massive supernovae literally punch holes in the interstellar medium, creating these expanding bubbles. And as the outer edges of those bubbles plow into the surrounding gas, that immense pressure triggers the birth of brand new stars. So our local pocket of space was carved out by violent stellar deaths, which then act as nurseries for new star formation right at the edges. Pretty cool, right?
Moving on to Part 2, the local group and beyond. Let's leave the Milky Way behind.
So, the crucial point here is mapping out our actual cosmic address. To do that, we have to scale up from our home in the Milky Way, zoom out into the local group, and from there we join the massive Virgo supercluster. And eventually, we see that it's all just one small thread in the overwhelmingly vast interconnecting cosmic web. Let's break these steps down.
All right, once we leave the Milky Way, we enter intergalactic space. Here, our galaxy is just one of many in a cluster known as the local group. It spans roughly 10 million light-years and holds over 50 galaxies. But it's really dominated by two heavyweights, our Milky Way and our neighbor, the Andromeda Galaxy. Together, they essentially act as these massive gravitational counterweights in a cosmic dumbbell structure. They're literally what holds this local cluster of dwarf galaxies together in the dark void.
But get this. Even that colossal 10 million light-year dumbbell is just a tiny speck plunging towards the center of an even larger structure, the Virgo supercluster. Guys, we are talking about a region of space 110 million light-years in diameter. It encompasses our entire local group and contains thousands upon thousands of individual galaxies, all organized into over 100 smaller galaxy groups and clusters. The gravitational pull here is just immense. All these groups, including us, are basically falling toward a common center of mass in the Virgo cluster. Which brings us to Part 3. Welcome to Laniakea. This is our true galactic home.
Now, we're entering a structure so vast it honestly almost defies human comprehension. You see, the Virgo supercluster isn't the end of the line. It's merely a single branch of something much, much grander called Laniakea. That's an absolutely beautiful Hawaiian word that fittingly translates to immense heaven. Laniakea spans a mind-numbing 500 million light-years across and contains over 100,000 individual galaxies.
To really put that scale into perspective, the mass of Laniakea is a staggering 100 million billion suns. No, seriously, it is a true gravitational masterpiece. Every single one of those 100,000 galaxies, along with their supermassive black holes, their billions of stars, and all that dark matter, is completely bound together in this sweeping cosmic web of attraction and motion. Think of it kind of like this. Laniakea is structured almost like glowing interconnected cities on a dark, sprawling map. You've got these cosmic highways, known as filaments, that literally guide the flow of galaxies. But here's the crazy part. As enormous as Laniakea is, It's still just a single node, just a single glowing metropolitan area in the overarching cosmic web that spans the entire observable universe.
All right, part 4, the Great Attractor Mystery. Let's look at the heart of the pole.
So, returning to our initial mystery for this explainer, what exactly is pulling us? Well, located at the very core of the Laniakea supercluster lies the answer: the Great Attractor. This is a massive, highly dense, and super mysterious region of space that exerts a monumental gravitational pull on everything around it. It's the literal focal point that our Milky Way, the entire local group, and the rest of the Virgo supercluster are hurtling toward. Everything in our cosmic neighborhood is just flowing like rivers of light down a gravitational valley toward this central anomaly.
And what makes this absolutely fascinating is that it sets up this massive cosmic tug of war. On one side, you've got the fundamental expansion of the universe, driven by dark energy, trying to stretch space and push galaxy clusters apart at accelerating speeds. But on the other side, you have the localized, overwhelming gravity of the Great Attractor, forcefully dragging our entire supercluster inward. The Great Attractor is so phenomenally dense that its gravity is actually overpowering the expansion of the universe in our specific local patch of the cosmos. It's incredible.
And finally, part 5, the limits of our view, peering to the edge. You might be wondering, if it's so massive, why is the Great Attractor still somewhat of a mystery? Why don't we just point our telescopes right at it and figure out what the whole shebang is made of? Well, it helps to remember that the entire observable universe, meaning everything we can theoretically see, stretches about 93 billion light-years in diameter. Now, wait a minute. If the Big Bang happened 13.8 billion years ago, how can the universe be 93 billion light-years across? The answer is cosmic expansion. Space itself has been stretching since the dawn of time, carrying light and galaxies along with it, and constantly expanding the physical boundaries of what we can observe.
But here's the kind of terrifying catch. Because space itself is stretching, and doing so at an accelerating rate, the furthest reaches of the cosmos are actually expanding away from us faster than the speed of light. Now, this doesn't violate physics because the objects aren't moving through space faster than light. Space itself is expanding. But the result? The light from those distant regions will never, ever reach us. Those areas of the cosmos are lost to us forever, just slipping quietly over a cosmic horizon.
Which leaves us with this final, truly mind-bending thought to take away from this explainer. If the Great Attractor is pulling our 100 million billion sun supercluster toward it, and there are entire regions of space slipping away from us faster than light, what immense heavens, what other mysterious attractors, and what completely unfathomable structures lie out there in the dark, forever beyond the edge of our cosmic bubble? We might never know for sure, but honestly, that search for answers is exactly what keeps us looking up.